Hi, I'm Haixuan Tao. I work for the Banque de France, and today I want to talk to you about ONNX and how ONNX is helping us, Banque de France, provide better AI software for our activities. So, for a little bit of context, Banque de France is the central bank of France. We are part of the euro system, and we are in charge of the money supply, both physically and digitally. We are also in charge of the financial stability of the financial system. And recently, we have been trying to improve our activities with artificial intelligence. And for example, we are trying to increase the detection of fake banknotes. One of the problems with banknotes is that it can be really dirty, really dry, or really wet, and this is going to create a lot of noise. But thanks to computer vision, we have been able to reduce this noise and increase the signal to noise ratio for fake banknotes, for example. Another example of improvement with AI is in our detection of fraudulent transaction. So as a bank, we do a lot of transaction, but the thing is we do very big transaction. Most of our transaction is around millions of euros, and so each percent increase of fraudulent transaction detected is going to have a huge impact on the bank. And lastly, we're also trying to improve our retail bank supervision capabilities. So the thing is that with NLP, NER, and computer vision, we can be really agile and really provide a software that will be able to work on different banks with different IT system, different type of data. And this is really new, and we have been able to provide a software that can reliably work on varying banks, and this has been really great. And I want to deep dive a little bit how ONNX is helping us on this last case. So let's say we're going to supervise a bank together. Let's say we want to check for credit supervision. We want to make sure that the bank is making the credit for the right reason. Or another example is to do terrorism financing or money laundering. All the things we want to do supervision on. The thing we do at Banque de France is that we send an agent to a bank, and we're going to collect the database of the bank. So who are their customers? What are the transactions made by each customers, and what types of money do they borrow? How much did they borrow? So on each of these cases, we can use AI algorithm to enhance the capabilities of the agent, but it's actually really hard to do the computation. One typical way we would do the computation is through a cloud server. The thing is that it's really hard to do because there's a lot of security either at the retail bank side or either at our side, and there's also a lot of legal data protection laws that we can bypass, but there's a whole process and we don't want to go through that. One way we have found to do really kind of AI computation is directly on the laptop of the agent. And this has been really successful thanks to ONNX, because with ONNX, not only can you run deep learning models, but you can accelerate the deep learning model with GPUs, with execution providers. And so let's say the laptop is a Intel-based laptop, you will be able to increase the speed of the deep learning model with OpenVINO or DirectML. And if it's an NVIDIA laptop, you will be able to increase it with NVIDIA CUDA. And this is great because the faster the deep learning model will be able to run, and the more the bigger the client pool we can actually control, and the larger the coverage of the bank we have been able to do. And so this is great. But the thing is, from a maintenance perspective, having a lot of execution provider can provide a risk of installation issues or maintenance issues, or if you want to do upgrades. And so we have been thinking about building kind of a unique ONNX provider, execution provider that will work on all platforms. And the way we're doing this is using, we have been trying to do this with web GPUs, because web GPUs theoretically could work on Windows, Linux, and macOS. And there's actually an implementation of web GPUs that is Rust-based called WGPU that can support Vulkan, Metal, and DX12. and therefore support almost all platforms. And in terms of performance, is actually pretty performant, being faster than WebGL, and so it's really promising. So I tried that, and so I've built a research project called ONNX, which is built on Rust and WebGPU, and I've tried to see if it could be done and if it could work on all platforms. And so I've implemented 40% of the ONNX operators, and I've successfully built an inference model, used an MNIST ONNX model and run it, and had the right results, and did a similar thing with QuizNet. And so it could be done, and I think I've done the proof of concept that it could be done, and actually, but now the bottleneck is the optimization of the provider. As of now, the squidness inference time with Wonks is about the same time as with the CPU with the Microsoft ONNX runtime provider. So I haven't really kind of made it work faster than the CPU, but I'm sure that with more aggressive optimization, I will be able to divide by 2 the time of inference, which will make it relevant enough for us to maybe switch to this web GPU based solution. So this is it for me. If you have any question on Banque de France or on Rust on web GPU, feel free to reach out. The code for Wonks is freely available on GitHub, and so yeah. So check it out if you want. All right, thank you very much.